So let's have a look at the recovery. So far I've been talking about kind of tree level. Let's look at stand level recovery of these 22 flathead stands. So this is the dead basal area at the time of the beetle attack, right, 1982 or something, say. And the black part down here are the live parts in the stand. And so this is, the basal area killed, right? And it was somewhere between, like 20% to 80%, and there was a few that were extreme. Like this one was pretty much entirely killed. And then there were some other ones here where, maybe only 30 or 40%, right? So, typical mountain pine beetle stuff. So how about 25 years later, which is the black bars on the right? And we'll just go one more here. Put some tick marks on them. So the ones with the little green tick marks are ones that have recovered really well. So like this one, stand number 22, 25 years later, it has more basal area than it did when the beetle hit. And this one's pretty much recovered. This one's pretty much recovered. There's a bunch of them that have recovered really quite well. And there's other ones that haven't recovered at all well. I think, do I have them? Yes, red X's on them. So, there's some like this one that's it's got some basal area, but it hasn't recovered all that well. But you could maybe understand why, because it got hit really hard. Then there's other ones that, that had higher basal area survival, but still haven't recovered all that terribly well. So like what gives? How do we sort that out? How do we, because obviously if we could sort this out, if we could understand this very simple dynamic, we could decide whether or not we want to do rehab and restore, right? So I don't totally understand this, and of course it may be, going back to what I said at the very beginning, it may be totally contextual to the flathead. It may be unique flathead data and not necessarily, that you should export it widely. But we live dangerously and we're exported widely. I think it's not bad. So what have I learned about this? I'm going to get to this. So, one more thing. There are a bunch of species in the flathead, so that's important. There's a bunch of kind of desirable conifers, and so that's a real nice thing about the flathead. You do get a nice kind of mixed species. Don't worry about the individual species. You can just see that a bunch of these stands that recovered well have a greater diversity of species in their recovered composition than they had before. So that's part of the story. If your stand has multiple species and they recover, you've got a better chance of recovery. If you're just pine and nothing but pine and a bunch of it's dead and you don't have anything else, you're in rougher shape. Chuck put up this and mentioned this study and put up one graph of it. I have another graph that I stole out of Dr. Rahm's paper in the American Naturalist in 1986. I think this is really, I found this a long time ago and I thought it was pretty cool. It's more or less exactly what I did. Then we went and studied the flathead, and we found pretty much the same thing. So the dark bars over here are undisturbed pine stands that didn't get hit by mountain pine beetle. And I think that the bar over here is the basal area pre-beetle, and then this bar is right after the beetle or something, and then this is the recovery. So, and these are just a couple different stands and different beetle epidemics. But anyhow, recovery. A bunch of stands recover well. And in the flathead, we found a bunch of stands recover well. So we need to understand who they are. And I will get a bit more to that in a minute. Let's look at the individual canopy trees and how they've released and gotten going. And Chuck put up some graphs like this. These are just percent increases in growth. It's like that ring core I just showed you. And these are for different species. And these are bigger trees. I think these are trees greater than 10 centimeters dBH or something at the time of the epidemic. So most of them release and grow well. Larch seems to be about the poorest. It didn't release all that well. The other species, spruce, subalpine fir, Douglas fir, all released well. And lodgepole pine released really well in these stands. And mind you, a bunch of them didn't grow that much. And we kind of remember that. I think I'm coming back to that in later slides. anyhow, most of them released, a bunch of them released, and they grow. So obviously the recovery of a stand is a function of how many trees you have left that are alive and their release. The best release is always in stands with the highest mortality. So if you have 90% mortality and you have 100 stems per hectare left alive, those 100 stems may release really well and may grow really fast, but the stand can't recover because you only have 100 stems per hectare. The optimal situation is where you have reasonable stocking and reasonable mortality to release that reasonable stocking. And then those trees all grow maybe less than the best release trees in the most damaged stands, but the stand recovers. So there's some optimal condition where you have enough surviving trees and you have enough mortality in the mountain pine beetle event where the stand recovers, although the individual trees aren't recovering as quickly as those in the heaviest hit stand. And I think that's the concept that has to be understood in recovery, is that it's a combination of things. Seedlings and saplings, they, the ones that were alive but less than, I think seedlings are less than 1.3 meters tall and saplings are taller than 1.3 but smaller than, 10 centimeters DBH at the time of the epidemic. And so they all released and grew pretty well too, except for, again, larch. Not a real good sample size on larch, but the 3 individuals that were out there didn't do too well. So now I'm going to turn really quickly to BC and permanent sample plots that we've just done. We've just started looking at permanent sample plots in British Columbia where we're remeasuring old permanent sample plots in mountain pine beetle stands. About 65 of them were done in 2012. I think another 60 or 70 were done in 2013. Haven't got the data from that yet. And there's a plan to do maybe another 60 or 70 in this field sampling season. And I think that's really important to do that, and someone yesterday talked about monitoring permanent sample plots here in Alberta. I think it's really critical to monitor permanent sample plots, but having spent a few months now trying to analyze the first 65 from 2012 field sampling, it's just a nightmare trying to analyze these things. I think it will be really easy when they're remeasured 20 years from now, but we kind of need the data now. We kind of need to understand what's going on now. And there's just a whole bunch of things, like they're attacked at different times, they were measured at different intervals before the attack. Even nailing down what year they were attacked. You've got this permanent plot, and what year was it attacked? It's even hard to figure that out, which is kind of surprising, but it is. They just find it hard to figure it out. And then, so it was attacked in 2007, and it was measured in 1998, and then it was measured in 2012. How do you figure out the growth rates? It's messy. It's very messy. So I just throw that out for people that are thinking of tackling this. You could really make it tidier if you could somehow get in and measure your plots 2 years after red attack. And it sounded like you guys were trying to do that, so that's tremendous if you could pull that off. Because then you've got a good baseline, and then if you measure it 5 years later or 10 years later or whatever, you kind of know what's going on. We started measuring these plots anywhere from 5 to 10 years after the beetle epidemic hit them. We don't even know exactly when it hit them. Yeah, it's messy. So if you can avoid that, I really encourage you to do it. So of these 65 plots, they're all over the place. We tried to get a range of pine mortality and percent pine in the stand, and this graph just kind of shows that of those 65 plots, it's pretty good. Some of them have really high pine mortality, but not all that much. Only 30% pine in the stand, they're all dead. Other ones have very high pine mortality and very high percent of pine, and so on and so forth. This was the basal area of these permanent sample plots before the beetle. And this is the basal area after the beetle. And the most striking thing here, there's all this talk about devastation and death, and all the stands are being killed and there's nothing left. Well, I mean, this was kind of a random sample of our permanent sample plots, and this is pre-beetle, this is post-beetle. there's lots of trees out there. I mean, this is basal area per hectare. This is 20. I mean, a whole slews of them have more than 20 square meters per hectare. And I'm going to return to that number. Tons of them have more than 10 square meters per hectare. I was just surprised by that, just how much living trees there actually are in all these mountain pine beetle damaged stands. This is similar to the other graphs I showed you. This is percent increase of individual trees, and Amlish Dart, who's a postdoc that was working in Smithers for about a year, has moved on to UBC Okanagan, did all this work. He sorted out as best he could when it was attacked, and pre-growth and post-growth. So this is after the mountain pine beetle attacked, and these are individual trees, and this is their growth increase. These are individual canopy trees, or their growth decrease after the mountain pine beetle. And this is in the period before the mountain pine beetle. So, like, how much growth increase occurred. If you have 3 measurements, you can sort out the period before the mountain pine beetle and the period after the mountain pine beetle. If you only have 2 measurements, you're in trouble. So there's 2 things I want you to get to notice here. One is how many trees are kind of doing really poorly after the beetle, and there's a bunch that are doing well. Just a couple more of these, just to kind of see what they look like. Here's another. Those are individual plots, by the way. Here's a plot. Trees are increasing in growth. This is what the growth looked like before the beetle. This was a stand that's probably fairly old. Pine growth rates are really slowing down. You got some of them perked up, but some of them are still growing slowly. This is. I showed you this graph earlier from the flathead, and these are pine trees. And these are pine trees from the current epidemic, and again, maybe 5 or 10 years of release. And there's all these ones down here doing poorly. And again, this is just pine. And this is after 25 years in the flathead. So what I think this is, these are damaged pine trees that have been hit by, they probably got some damage from the mountain pine beetle. They're not doing very well, and they're going to wink out, right? 10 years from now, these are all going to be dead, and your graph is going to look like this. There's still some trees that are slowing down. These are the trees, I think, all these trees underneath here, these are probably trees in the stands that only have 30% mortality. And so there's still a bunch of trees that are being competed with, and you still have basic successional processes going on. And the stands are getting older and the growth rates are going down. And these are stands with maybe 40, 50% mortality, and the growth rates have been increased. These are stands with 90% mortality, and the growth rates have already increased, but the stand can't recover because there's not enough trees. Now there was the lesser and greater cook yesterday. That's just a different way of putting it. And there was, the lesser cook had fascinating graphs and was talking about complexity theory and all the rest of it. And I just don't have a graph to compete with those curves and lines and thresholds and explosions. And it was pretty cool, but I almost got a headache listening to it. But it was totally cool from a complexity science point of view. This is the best I can do. This is these permanent sample plots, and this is really tough. I don't have the data, and we don't have enough time of mortality. So this is growth of the trees. This is percent mortality, growth of individual trees. This is pre-beetle. This is post-beetle, and you can kind of see that the lower percent mortality are kind of the same, and there actually is a little bit of a pulse here in the higher mortality, but there's some trees that are growing faster. It's just a different way of presenting what I've already been presenting. I'm kind of disturbed by the fact we got such a poor sample in here. This is what you really need, because I'm becoming more and more convinced that it's right in here are the stands that are going to recover well and that we need better data on. And I'm also fairly convinced that you go and get a hump-shaped curve like this over time. And that the best recovery is an intermediate disturbance with lots of trees surviving. And just a couple more lesser and greater Cook graphs. So in British Columbia, we're really concerned about the midterm timber supply. I mean, to a certain extent, you could argue that our accelerated harvest rates over the last 10 years have actually made things worse from a midterm timber supply, because we've harvested a lot of green trees trying to get all the pine trees. But of course, there were a lot of dead trees out there that needed to be harvested. So the midterm is the big problem, and a lot of the work that I've done is focused on recovery to improve volumes in the land base in the midterm, so like 10 to 40 years from now. You also want to think about the long term as well, but I've certainly focused on the midterm. So some projections, like if you have 5 meters squared of basal area, and you can have that in different distributions. What are these things? The blue is spruce, the red is pine, the green is subalpine fir. So these are surviving secondary structure. This is all spruce, and you've got across kind of a range of different diameters, and it adds up to 5 square meters. This is a whole bunch of subalpine fir and a bit of spruce. It adds up to 5 square meters, 1,300, 700, 1,200 stems, subalpine fir, some spruce adds up to 5 square meters. A bunch of spruce, one of the little ones, adds up to 5 square meters. So what if you stick those into a model and compare their growth rates to a spruce plantation? So the green line here is I think a 1,200 stem per hectare spruce plantation, and this is the basal area development of that spruce plantation according to Tipsy. And then I used the sortie model to model those 4 different 5 square meter things, and I just the model randomly distributed the trees, so they're not clumped, but they're not equally spaced either. But they're covering the whole stand. That's really important. The model is assuming that the stand is stocked and it's reasonably evenly stocked, and it also assumes that all those trees are healthy. So those are 2 really important things to consider. Neither of those may be true, and if neither of those are true, these yield curves are wrong. But if it is reasonably well distributed and the trees are healthy, these yield curves are good. I've compared sortie to Tipsy for spruce, and it does sort of the same thing, so I feel quite confident that these are reasonable. So you have a couple of these ones where they're dominated by spruce. They do really well, they release, so like those ones that had a nice diameter distribution, they release, they grow really well, they do much better than the spruce plantation overall. There's other ones, so pretty much all of these secondary structure ones do better in the midterm than knocking them down and planting a spruce plantation. One of them does a lot worse in the long term, but does better in the midterm. This is the one that was dominated by subalpine fir. Another one is pretty much equal, and 2 of them all around generally do better just because they're ahead, right? They're just simply ahead. Be like taking this curve and sending it out to here. So, what this says to me is that you've got to be really careful about thinking that logging will save you, that logging is the best way to save your stands. There's a lot of foresters that have already gotten caught up in thinking that the only way to save damaged mountain pine beetle stands is to log them. Well, I think a lot of ways to save damaged mountain pine beetle stands is just to leave them alone and let them grow. But you have to understand the composition. Obviously, if you have a bunch of buggered up trees, clumpy, what I'm saying doesn't work. So there's a lot of stuff you have to think about. This is an old slide from ecologic classification. Lots of stuff that has to be thought about. An old school forester like me would go out in the field with all sorts of manuals. I'm trying to train myself now just to take my iPad. I'm going to wrap this thing up to restore or return to my runaway. And this is kind of my thinking. It's a combination of research data and my personal opinion. So take it for what it's worth. The abundance of non-pine trees in pine-leading stands can often be pretty good. There can be a lot of them. And surprisingly large amounts of them can be in pine-leading stands. These are the 3 things that you need to reflect on. You need to know something about the abundance of non-pine trees in pine-leading stands. You need to know about the growth of surviving trees post-beetle, including pine, that survived the epidemic. And you need to know something about the regeneration dynamics, whether you already have an existing seedling bank or how long it's going to take you to get regen. And these 3 things, in various unique combinations, will guide you as to whether or not you need to restore or rehab the stand, and will also guide you as to how quickly the stand will recover. So recovery will depend on the unique combinations of these factors, and really doesn't lend itself to any kind of general rules. It is site and from my from the research, in my opinion. You should probably expect a regen delay of up to 10 years and then a pulse of regeneration, especially in moss-dominated systems. Many stands have a well-developed understory of advanced regeneration, and if this is the case and they're healthy, you have no regen delay. You're just going to get more stocking over time. You're in good shape in terms of understory stocking. And maybe that's understory. Generally speaking, surviving trees should release well, unless there's something wrong with them. I mean, there's lots of stands where there actually is something wrong with them. Maybe it's a relatively pure pine stand, and the only trees that survived the epidemic are all these suppressed understory pine, and they've got mistletoe. So it's not a good situation, right? But if the tree is healthy, has a good crown, isn't damaged in some way, generally speaking, they release well. It seems pretty apparent to me now that if the trees are healthy and you have more than 20 meters squared per hectare of live basal area of pine or non-pine species, the stands could recover in as little as 20 to 30 years. So clearly, you don't want to be rehabbing those. If you've got 10 to 20 meters squared per hectare, you've got to get back into the stuff I talked about earlier. Is it well distributed? Are the trees healthy? It's not clumpy. Then if all those things, you can go tick, tick, tick to all those things, and you got more than 10 square meters, they're probably going to recover too. Or they're certainly going to grow at a growth rate similar to a plantation. So why make a plantation? Your growth rates are pretty good. I didn't do the graph, but I looked at those flathead stands, and I didn't have time, but I was thinking about, they were growing as well as a tipsy growth curve, even though they hadn't recovered. They hadn't recovered in 20 years at post-beetle. Their current growth rate was just as good as a plantation growth rate. So I think those are these ones, the 10 to 20 square meters. If you can get as good a growth out of them as you can get out of a plantation, why make a plantation? You get below 10 square meters per hectare, everything needs to be right. It's got to be well stocked, it's got to be healthy, everything's got to be perfect. And then it's got a good chance of growing just as well as a plantation. If it's not perfect, if it's clumpy, you don't have enough stocking, the trees aren't healthy, they're tall and spindly or something and high risk of snow damage, then that's the kind of stand you want to restore. That's where you want to do rehab. So my personal opinion is that foresters have been too negative. That foresters have knee-jerk tend to think that we need to rehab, that we need to fix this problem. And in many cases, the best thing to do is to do nothing. But you have to do nothing in the right place. And that worries me as a forester, because I've seen too often where we've logged in the wrong place and done nothing in the wrong place. We have a really bad habit of that as foresters. We log the stand that's close to the mill, that has road access, that would recover really well, and we leave the stand that's far away from the mill that desperately needs rehab. So, that deeply troubles me as a professional forester, and I've seen far too much of that in British Columbia. So I hope you guys don't repeat that story.